In this problem, a uniform rod of mass 20 kg. So let us take down the data. 20 kg and length 5 meter leans against a smooth vertical wall, making an angle 60 degrees with it. The other end rests on the rough horizontal floor. The friction force that the floor exerts on the rod is G value is also given. Right. So what in the problem they are mentioning? There is a wall like this. Floor is also there here. Right. This wall is a smooth wall. This is rough surface, rough floor. Right? Here one ladder is placed, one rod is placed. Rod is touching the rough surface at A and smooth wall at B. Let us see what are the forces acting at A and B. Whenever rod is placed on rough floor applies a normal force on the rod. And rod, because of its weight, it want to slide like this horizontally. Immediately, frictional force try to stop that action. So this is the direction of frictional force. When we place rod on smooth wall, this is the direction of normal force acting. Here, smooth wall means frictional force is equal to 0. Rough force frictional force we have to calculate. Here the angle is given as 60 degrees. Not only so, exactly the center of the rod at C, center of mass, weight of the rod vertically acts downwards like this. So this mg also making 60 degrees with the rod. Right? This is the scenario, the given problem. Here the ladder is not moving. So it is in static equilibrium. The rod is in a static equilibrium. So what is the condition for static equilibrium? Number 1, net horizontal force, translatory motion, it stops by the force, net force is equal to 0. So let us see forces acting on x-axis, whether they are becoming 0 or not along x-axis. It must be 0. So here along x-axis, in the x-axis direction, frictional force is acting. In opposite direction, N2 is acting. So these two forces nullify the force. So the net force becomes 0. So N2 is equal to F. Next, along y-axis. Along y-axis, mg is acting and N1 is acting in opposite direction. These two forces cancel each other and net force becomes 0. So N1 is equal to mg. Next, net torque must also equal to 0. So here when net torque becomes 0, for easy calculation we take torque in clockwise direction forces is equal to torque in anti-clockwise direction. Moments of forces about a point must also becomes 0 when a rod is in static equilibrium, right? So let us see which is in a clockwise direction. See, this mg is the torque, the moment of force mg is in clockwise direction. So torque formula, force into, this is the direction of force, and perpendicular distance from the axis of rotation. A is a fulcrum or axis of rotation. See, the rod we placed on the wall like this. So this is axis of rotation. So at axis of rotation, torque always 0. The distances must be calculated from the axis of rotation. So see, the force mg into the perpendicular distance from the force to axis of rotation. See this distance AF. See, if it is 60 degrees, this is 30 degrees. And CA to C, this is half of the length of the ladder. So this L by 2 in the direction of AF, x-axis, this AF value becomes L by 2. This is adjacent to L by 2, 30 degrees. So L by 2 cos 30 degrees. So torque formula, force into perpendicular distance from the force to axis of rotation. That is, perpendicular distance came as L by 2 cos 30 is equal to anti-clockwise direction. Which one is in anti-clockwise direction? Moment, which force is creating anti-clockwise moments? N2, like this. So N2. So this is the direction of N2. This is the axis of rotation. N2 to axis of rotation, the distance, perpendicular distance we need. A to this point, this distance, perpendicular distance. What is this one? Total length of ladder is, length of the ladder is L. Length of the rod is L. Length of the rod is L. See, this is 60 degrees. So this angle also 60 degrees. So this is L. This distance is L cos 60. Why? Because this side is adjacent. So this distance is nothing but L total length, L length of the rod, L cos 60. So into L cos 60, right? This values let us write. M is equal to 20, G is equal to 10, L is equal to 5, cos 30 root 3 by 2, N2, L is equal to 5, cos 60 1 by 2. 5 cancels, 2 cancels, 2 ones, 2 tens. But what we know, N2 is equal to F. So F is equal to 10 into 10, 100, root 3, force. So it is Newton. So this is the frictional force acting on the rod. So answer is second option is the correct option.